How's everyone doing? Good? Good food? Good people? Awesome. Thanks for coming. It's fantastic to be here. You may be here for building reactive views with the architecture components. I have pulled a little bait and switch, just a little bit for the title. I was getting some code for this talk reviewed by some colleagues, and one sort of said, this is like kind of like an a la carte ViewModel thing, and I was like, oh, I really like that name, so I'm going to take it. So sorry if you were here for one thing, same content, different title. I'm Sam. I am an Android developer at Slack. I work on the new user experience team primarily, which gets people on and in and created for the Android app. And I'm going to sort of walk through how at Slack we went about revamping our sign-in process, our onboarding process, pretty heavily. And along the way, ran into some architectural challenges, and kind of enumerating those and how I applied this sort of a la carte ViewModel style to what we're doing. So, without further ado, there won't be a test on this stuff. It's a little dense, but this is onboarding at Slack. This is signing in. This is the process. And a year and a half ago, it was really complicated. It's an enterprise chat app, right? So there are things like SSO, and there are things like two-factor authentication, and we have to integrate with a lot of different identity providers. And the challenge was going from this to this, and that was sort of what we set out with, was simplifying and kind of like coalescing our login flows completely together to be harmonious and get people in and on and created much faster. And so a year and a half ago, we had these designs, and we started looking at the mockups here, and we started noticing that a lot of these screens have shared functionalities. And if you look here, this is basically pre-auth and post-auth. You can sign into multi-factor auth workspaces kind of from two parts of the app, right? Pre-auth, post-auth, and we were thinking about how we can sort of share code between screens like this. And also, they switched teams to workspaces, the name for them, like halfway through my time at Slack. So if I refer to a team or a workspace, they're the same thing, but in my head and in my data layer, they're all teams. So we looked at these screens, and we kind of looked at our current architecture, which looks kind of like this. We use a very vanilla model view presenter, and we expose an observable interface on our model, which sort of does changes to our data and then reacts. The RX in the presenter sort of reacts accordingly. And this pattern has worked really well for us, but it came with a couple of drawbacks when trying to share code between different screens. So this is like a normal contract that you would have with vanilla MVP. And it's fine, right? Like it's pretty succinct and stuff. But the issue is, you're defining a contract here between your view and your presenter, and those methods on the view are basically callbacks that you're going to call from your presenter. And that sort of abstracts your view behind this nice contract that you can then unit test. So the issue is that these things grow exponentially. Especially with login, we have a lot of different code paths. You can log in with standard auth, you can log in with SSO, you can log in with two-factor. And then each one has its own pretty much success, right? Because we sometimes need to open up Slack to different parts of the app depending on where you're coming from. If you're coming from an SSO, there's a good chance that we're opening up enterprise grid onboarding. If you're coming from two-factor auth or standard auth, we're going to probably open up the regular screen. And then we also have some other nav tutorials and stuff like that we need to notify basically our home screen of. So it was hard to push these things together, and we ended up with a lot of contracts that were very large and hard to reason about. And the worst part about all this is when you're trying to share these presenters across screens, like not all of them use all of your presenter or view callbacks, right? So this is a screen where you can have multi-factor auth workspaces or teams, but you really can't have standard auth workspaces. So now you have code that looks like this in your activity, where it's not defensible, right? Like, let's say a dev comes by and they're like, oh, I want to use this login presenter. Let me just sort of attach it to my screen via our MVP contract, and all of a sudden you have callbacks that aren't being used, and if they don't know to like throw a legal state exception there, or they don't know really what's going on, it doesn't really extend well for future developers. So we went back to this, and we're like, well, how can we around this time, we sort of we're adopting Kotlin, and I got really, really into the idea of the model view intent architecture, which, if you're not familiar with model view intent, sort of models your entire screen or view state as a reactive stream, which I thought was brilliant and amazing, but also a little untenable for a legacy code base. You have to have a lot of knowledge of RxJava and sort of the more obscure operators. And at Slack, we are not ones to kind of jump into new untenable things without thorough research. Some would say maybe too much research. Also, I think some of this is sort of born out of fear of alienating some of our users, especially with login. And there's also a great story about how he locked the CTO out of Slack one day. So ask me about that later. So we looked at this and we thought, how can we make this more extensible? And specifically starting with the presenter, we were adopting Kotlin. We were sort of like, oh, I can sort of borrow some of these things that MVI uses. And one of the things that MVI uses is these action classes or event classes, as we began to call them. And this event class basically models all the actions that you would want a presenter to take. If you're not familiar with sealed classes, they're a Kotlin mechanism of essentially modeling restricted class hierarchies. And the only difference between them and enums, they're very similar, is that they can contain state and they can return multiple instances. So this is really powerful, right? Like this is very deterministic. This is a class you can check an instance of on it. You can use the Kotlin when, which is super fun. And like I mentioned, so we found that in our presenters, instead of like exposing all of these extra methods on our presenter, we can now encapsulate a lot of what we were doing kind of publicly, privately, and expose just the one entry point, which is the one function that takes an action and routes appropriately. So this was great. I look at this code a lot because it's actually very pretty. But we had a great time with this. We had a lot of success. And we thought, we want to take this a step further. Of course, this is the presenter. Let's sort of apply it to the view. So we looked at the view, and we did sort of the same thing, which is we sort of smushed everything down into a single entry point into the view instead of multiple obscure entry points with this result class. And the result class modeled the success that you wanted to see on any screen. And you really probably want to make these more generic, which we have with sort of a resource-backed result or whatever it is. But you can see that you can have nested hierarchies here. So this is a great Kotlin feature, is the sealed classes and nested sealed classes. So we on login do a lot of this is success. You were a successful login. Now you have an auth token, but you still have to two-factor auth into the app. Or we can't get you any further until you SSO login. So we usually want to return success, but a flavor of success, and sealed classes were a great way to do that. And we have error and in progress here, and really where the magic occurred, and I borrowed a lot of this from model view intent, is how we were using, that was a really unnecessary animation, how we were using sort of error and in progress, but to illustrate that, I'm going to like kind of show you how we were using them before, right? So this is the old MVP. And we're doing a lot of really bad things here, right? Like this looks normal, this looks fine. You can see it at the top where we're toggle loading before we're even subscribing to any service. Like now you have your view and your presenter, and now you're trying to basically juggle the state and reconcile them between your view and presenter, right? So you've started off with like, oh, this is a dumb view by MVP standards, but I'm really manipulating it from my presenter. And then on top of that, some of that manipulation is happening inside of an RX stream, which is super not thread safe, right? Like you could be toggling a loading spinner, you could be displaying success, you could be displaying error, and you're sort of like reaching outside the stream to mess with the view, which is, really not thread safe. We're not being immutable. We're not doing, good things there. So to kind of illustrate, well, I really put a lot of animations here. To illustrate how we were using these result classes with our new sort of pattern here is this is, a typical, like we want to subscribe to a service and we have this event and we can map whatever we want, whatever the outcome is to a result class, your success result class here, and you can pass params through. And so now you're always going to get the same return type, which is nice for a lot of reasons, which I'll talk about in a bit. But we're using on-error return here, which essentially like wraps your error and throws it back into the stream with the type that you specify to a sealed class, this error sealed class. And now we've folded this error back into the stream, and we can react to it appropriately. And the same thing with start with in progress. Every time we subscribe to a service, we're going to emit, the first thing we're going to emit is essentially an in progress, right? And then we know when progress has stopped when we're displaying something else, like an error or a success or something like that. So the call site for this is really nice. You can when on the result, and now you have all these very deterministic things. And one of the things that I think I got a lot of pushback on when trying to pitch a pattern like this was, oh, like you're pushing more things into the view. Like let the view be as dumb as possible. And I push back on that a lot because it's a very naive understanding of what the view and the presenter should be doing, right? So like MVP says, oh, we've separated concerns, business logic, view logic. But I mean, here, you're still messing with the view from the presenter, so you're not really separating any concerns. You're just sort of entangling it a little bit further, but in an abstract way where you can unit test it. So like that's good because you can unit test it, but you're still kind of messing with the view. So my argument for this is that, too far. My argument for this is that really the view is doing what the view should be doing, which is showing and hiding views and toggling progress bars, while your presenter is just passing the result straight to the view, and it's none the wiser about the state of the presenter of the view. And that I think is a lot cleaner than trying to sort of reconcile these two things all the time. So this was our original contract, and I sort of edited it for brevity, but we've gotten it down to this, which is phenomenal. We have 4 discrete methods here, and they're very testable, and it's great. But really, we've done all this work to disentangle the view from our presenter, our business logic. But we really still have an issue with this attach and detach, right? We're still basically forcing the view into the life cycle into the presenter. And so when we have an architecture that looks like this, really, it looks a lot more like this. So this is bad, right? Like you have done all of this work to make these sealed class hierarchies. You've done a lot of things to, sort of like separate your logic, but yet you're still pushing your business logic into your view lifecycle, which like is just sort of like a really dumb move in a lot of ways. And so I was thinking about, well, how can we get rid of the attach and detach methods? How can we completely and totally decouple this presenter from the life cycle? And about a year ago, Google introduced something called a ViewModel. And just to illustrate this point a little more, ViewModels were introduced last year, as I said, and they live outside the life cycle, and you don't really have to do any life cycle management with them. And they use retained fragments under the hood, so when a lot of other developers at Slack are like, I don't really trust these new architecture components. I'm like, well, we have these janky old retained fragments like lying around. Do you trust them? And they're like, well, yeah, they've been there forever. I'm like, this is a retained fragment with a lot of niceties. So, it's injectable via Dagger. You can create a provider factory for your view models, and it works really well with what you already have. If you're on Dagger 1, like some legacy apps that I won't mention, but that definitely rhyme with or may be Slack, it's a little harder. If you're on Dagger 2, it's a lot easier. So this is essentially how you're using your presenter and this is how you're using attach and detach in our presenters. And if we get rid of these, we're going to get rid of this view callback, right? So we kind of had to figure out a way to be able to get rid of those. And if you look at what we're doing here, this doesn't have a return type. So we're going to have to change that because we can no longer push things into the view. So first of all, we're going to have to extend ViewModel. And then we want to return, in our case, an observable with our result class. And that ended up working really well. And now you can pass these view models around and everything. And this is basically how you get a view model. So login view model, the class, and the activity that it's scoped to. And it can be scoped to either an activity or a fragment. You can, they essentially make a canonical key so that every time you're querying for this particular view model that's scoped to this activity, you're getting the same view model back every time, or you're getting one created if it's not already created. So now you have a singleton instance of a view model that lives outside the lifecycle that's returning an observable of your result class that you can win on, and you're pretty happy. And this is how you would set it up, right? So you have this render function that I showed you before, and you have a click listener, and this is basically everything you need to log into Slack. If you put this code in Android Studio right now, it would work right away. The best part about, I think, all of this is that, and also you should probably null out your click listener so that you're not holding like a reference to the view model and stuff. But the best part about all of this is that they are just as testable as anything else, right? As your MVP setup. So you are returning like a success from your underlying data layer, and you can set up this test subscriber on your view model, and essentially assert the value of the result class, and it works really well. So that's really it. Appreciate everyone coming out. Questions? Comments? Concerns? Insults? Super insults? Oh, I appreciate it. Thanks. A little too many, but yeah. All right, well, this is that clear. You all can now develop Android apps at Slack because you have no questions at all on all of that. Or it was just that bad. Whatever. Either one. Cool. All right. Yeah. Oh, thanks, man. Appreciate it. Cool. All right. Thanks, guys.